For years, Chrome has been the subject of jokes regarding its memory consumption. But recently, something changed. Google quietly integrated Gemini Nano, a local large language model, directly into the browser engine. While the marketing focuses on privacy and AI-powered features like Help Me Write, there is a hidden tax being levied on your hardware. When you enable these features, Chrome doesn't just use a bit more memory. It carves out a massive, persistent block of your RAM, often exceeding 4 gigabytes. This isn't just standard browser bloat. This is a fundamental shift in how applications treat your local resources. We're moving from a world where the cloud does the heavy lifting to one where your browser expects to own a significant portion of your silicon just to stay idle. To understand where that 4 gigabytes goes, we have to look at the architecture of WebGPU. Unlike traditional web features, Gemini Nano runs natively on your graphics card, or NPU, through a layer called WebGPU. This allows the browser to execute complex tensor operations without sending data to Google servers. But LLMs are weight-heavy. Even a compressed model like Gemini Nano requires its entire weight set to be loaded into memory to function with any reasonable latency. When Chrome initializes its optimization guide, it triggers a massive allocation. It's not just the model weights, it's the KV cache, the temporary memory the AI uses to remember the context of your current conversation. As your prompt grows, so does the memory footprint, often ballooning until the browser is forced to swap other tabs to disk. A 3 billion parameter model, even quantized to 4-bit precision, takes up roughly 1.5 to 1.8 gigabytes just for the weights. But Google doesn't stop there. To ensure the AI feels snappy, Chrome allocates a pre-warmed buffer. Then there is the context window. If you're summarizing a long technical document, the key value cache stores the mathematical representations of every word you've processed. For a 4,000 token window, that's several hundred megabytes of high-speed access memory. Finally, there's the overhead of the WASM runtime and the GPU shaders. When you add it all up, the optimization guide service in your task manager isn't just a background process, it's a resource hog that rivals the operating system itself. Google calls this optimization, but for users on 8 gigabyte or even 16 gigabyte machines, it feels like a regression. In a dense system view, we can see how this affects multitasking. When Chrome grabs that 4 gigabyte, it triggers memory pressure signals to the OS. Your IDE, your slot client, and your other browser tabs are forced into compressed memory or swapped to the SSD. The irony is that the AI meant to make you more productive actually slows down the rest of your workflow by starving your applications of physical RAM. This is the Chrome AI lie. The promise of seamless integration masks a brute force approach to local compute that most laptops simply aren't ready to handle without significant performance degradation. So why is Google doing this? The answer lies in the privacy path. By running the model locally, your data never leaves your machine. This solves the massive privacy hurdle of cloud-based LLMs. When you use Help Me Write on a sensitive email, the tokens are processed by Gemini Nano inside a sandbox process. This architectural choice is a win for data sovereignty, but it's also a strategic move by Google. By shifting the compute cost from their billion-dollar data centers to your personal hardware, Google saves massive amounts of money on inference costs. They are effectively crowdsourcing the electricity and silicon needed to run their AI features, and you are paying for it with your battery life and system snappiness. If you value your RAM more than a built-in grammar checker, you can reclaim your memory. The optimization guide can be toggled off in Chrome settings, but to truly kill the service, you may need to venture into the Chrome flags menu. Look for Enables Optimization Guide on device and set it to Disabled. Immediately, you'll see the 4 gigabyte allocation vanish from your task manager. For most users, the trade-off isn't worth it yet. Until local models become significantly more efficient, or until we all have 64 gigabytes of RAM as standard, the browser as an OS philosophy is going to keep hitting this hardware ceiling. You have to decide, do you want a browser that helps you write, or a browser that lets you actually run your other apps? We are entering a new era of software, where local first is becoming a buzzword for resource heavy. Chrome's move is just the beginning. As Windows and macOS integrate their own local LLMs, the fight for your RAM will only intensify. The question is no longer how many tabs you can open, but how many models your system can sustain. Chrome isn't just stealing your RAM, it's redefining what a browser is supposed to be. Whether that's a lie or an evolution depends entirely on your needs. Thanks for watching.